Hey, I'm Avi. I'm here to talk about software architecture diagrams. I'm not sure how to pronounce the sparkles. As data. Um, I just want to say there's a really cool talk happening next door, so I won't be resentful if anybody decides to move over, because I wish I could be there. It's a really cool topic. I won't be offended, I promise. So, in the spring of 2016, I learned something that blew my mind. More specifically, I learned something mind-blowing about how my mind works. I was scrolling through Twitter, and I came across this tweet by Blake Ross. He wrote, "I'm 30, and I just realized that people can actually picture things in their mind. I can't. It's called aphantasia." So I read this, I did a double take. I said, holy shit, and I immediately clicked that link. And I read this essay that he had just written. Again, my mind was blown, like twice, blown, and the remnants were blown. And that's how I found out that I have aphantasia. That's a neurological variation, which means I don't have a functioning mind's eye. It means that I can't make images in my mind. I don't see images, I don't visualize. And this is how I felt at that moment. I wrote, this explains so much of my experience in the world. Holy shit. Now, I don't have time to go deep on aphantasia. We can talk about that after this talk. But it did seem to explain many quirks and oddities about me. So I'm not just a regular geek, I'm a quirky geek, I guess. I don't know. So in particular, it seemed like it might explain some quirks of my memory. See, my memory has always seemed to work a little bit differently than other people's, or most people's, in a bunch of different ways. But one specific way is that I'm basically incapable of memorization. I just can't do it at all. And it's not that I can't learn. I can learn new information, I can access information that I've learned. So I can learn, just not through memorization. In fact, I wouldn't even know where to begin to try to memorize something. Throughout my entire life, my school career, which ended abruptly, I tried to memorize and I failed every time until I just stopped trying. I just baffled until recently. So instead, for me, the only way for me to retain anything usefully is to really learn it. To learn a set of information as a system, as a network of connected information, a web, to understand it. The thing is, to truly understand something, some set of information, it takes time, often a lot of time. And in a world that often equates memory with intelligence, I've developed habits and strategies to compensate for my inability to memorize. For example, I rely heavily on reference documentation while writing programs. And not just while writing programs. When I'm operating in any context that I don't understand deeply, so for example, maybe I'm in a new context. I'm a blank slate. I need documentation in that situation, especially reference documentation, in order to operate in that context. For example, this is my first visit to North Carolina. For this situation, the reference docs that I need are maps. Many of us use these visualizations to orient ourselves, to locate ourselves, to navigate within unfamiliar environments, and to learn those environments. But if you think about it, we don't stop using maps once we've learned the geography of an area. So think about that for a minute. Even after we've learned the geography, even after we know it, we continue to refer to maps. Even those of us that have visual memories, which I guess might be most of us, I don't know, but not me. But even those of us that have visual memories can continue to refer to maps, even if maybe it's happening in their heads. So why is that? Why do we continue to use maps even after we've learned the geography of an area? Well, I think it might be because the maps serve as a sort of external memory. They help us organize and access the information we have in our heads. So we have maybe loaded a portion of the information in the map into our heads, but not all of it. So, when we refer to the map, we look at that map and we're looking at it. We're not just looking at it, we're kind of taking in the structure of the information and the additional information that's enriching, that's there that we couldn't kind of onboard, that we're enriching. So we're kind of doing a join of the structure and the data set in our heads with the structure and data set in the map. So it serves as a sort of external memory to various degrees. Some people maybe can memorize all of it. Just it's all there. They can zoom in their minds. That's amazing. Some of us just have the basic geography and we need to use that map frequently to enrich that and add more richness to that data. I'm saying the word rich a lot, so bear with me. So just to recap, maps are extremely rich with information and structure. I mean, someone who's not familiar with an area can use a map to get oriented, to get familiar, and then dig deeper and learn more. Once a person is already familiar with an area, they can continue to use that map to fill in the details that they couldn't commit to memory, to learn more and more over time. So maps are a rich, sophisticated, and powerful visualization medium. But they didn't start out that way. This is a map of the Babylonian city of Nippur. It's about 3,500 years old. And that means it took us 3,500 years to go from simplistic maps, like the one on the left of Nippur, to rich, sophisticated maps, like the one on the right of central North Carolina, sorry. So now, I'd like to take a look at a similar visual medium, one that has great potential, but is very young. Just as geographical mapping was a young medium 3,500 years ago, let's take a look at software architecture diagramming. No cheering? This is an architecture diagram that I created about 7 years ago. And I think it's okay, but it's fairly primitive. To me, it's closer to the Nippur map than to the North Carolina map. And this is a much better software architecture diagram, one created in the past year or two. Some of you might recognize this. Some of you might have even created this. I don't know who's out there. But this is an excellent diagram. It's a good way to illustrate the deep potential of the medium, which is to engender powerful, effective, efficient learning, both quickly, up front, and also over time. See, I found that for me, a diagram of a software system is akin to a map. It's a way for me to get my bearings in that system quickly so I can get right to work and be effective well before I've attained a comprehensive understanding of that system or set of systems. Because I will eventually commit those structures to memory. One way or another, I will learn them, and I'll be able to recall the elements and their relationships, not visually, but semantically. But I think this is why I find diagrams so crucial when I'm in a new context, because they enable fast and effective reference and fast and effective learning. And also reference over time and learning over time. And this may be especially true for me and people with aphantasia, but I suspect this is also true for neurotypical people. So diagrams, again, fast and effective medium for reference and learning. And let's take a look at this example again. It's an excellent example. It's an excellent diagram. But if we use it as a sort of a marker to discern the development of the medium, this visual medium, well, I think this medium is still not quite as far along as geographical maps are. I put it somewhere in the middle in terms of this timeline of progress. So there's still some work to do. There's some problems to solve. There's some progress to make to develop the medium to fulfill its potential, to move us further along to the right. Now, as someone who creates a lot of diagrams, my personal obsession is with how we create them, the tools, the techniques, the processes, etc. And, well, there are some problems. So architecture diagrams themselves, the what? They're great. But the tools, techniques, processes, patterns we employ to create and maintain these diagrams, the how, not great. See, over the years, I've encountered a whole bunch of problems, and I'd like to share some of these experiences with you. There were the many times I joined a new team, and I asked someone, are there any architecture diagrams? And the person I asked would just say, oh, just come with me, and lead me over to a whiteboard and just start scribbling like crazy, like furiously scribbling with a stream of consciousness narration with results that were generally less than coherent and definitely not correct. And this has happened many, many times. There was the time I joined a new team and I started looking for diagrams, and I found some diagrams printed out, pinned up on the wall. Cool. They're pretty good, but they needed to be updated. So I asked someone who made them and when, and I just got shrugs. I almost got like, really? You think we would know that? Somebody said, oh, I'm not sure. I think maybe they left last year. They were not concerned. There was a time I asked someone to work with me to update a diagram, and they declined because, this is a quote, again, I'm asking them to update some documentation with me, and they declined because they said, documentation is always out of date. Okay? What can I say to that? There was the time I wanted to update a diagram that someone else had created, some mysterious person. And against all odds, I actually found the source file. That never happens, but I found it. But then I couldn't do it because I didn't have this proprietary and expensive software license. Couldn't open that proprietary closed file format. There were the many, many hours I wasted fiddling with diagrams to get their elements laid out evenly and consistently. And I hated every moment of those hours. Because, what the hell? Computers were supposed to eliminate this kind of drudgery decades ago. Bicycle for the mind, my ass. So to summarize, many software architecture diagrams today are ephemeral and ad hoc, when they should be artifacts that are maintained and improved thoughtfully and carefully over time. Many diagrams are created as just a bunch of boxes and lines, without any specific method or conceptual guidelines for, maybe what should be in and what should be out. Most diagrams are created and stored in individual people's devices or accounts when they should be in a single shared corpus, where anyone in an organization could discover which diagrams exist and which don't, could find the source of each diagram to change it, and then change history to see who did what over time. Most diagrams are using file formats that are proprietary and can be edited only with the tool that was used to create them, when they should use file formats that are open and interoperable. And most diagrams are created in GUIs that are basically illustration tools. And they often require authors to spend a lot of time in layout, positioning, styling, and thinking about illustration, when they should be using tools that are specifically for diagramming and therefore handle a lot of that stuff automatically and let you focus on architecture and on that creating that learning experience. So when I think about this set of problems, this is how I feel. And over the years, I've done my fair share of ranting and raving about these various problems, and most of the time, people just go, really, more of this? But it turns out, I'm pretty excited because over the past few years, I've sort of discovered and realized that there is a solution. And it's a technology that most of us are probably pretty familiar with. Data in text files. Big reveal, big reveal. Okay. Data in text files is a very exciting new technology. Let me explain. Now, as many of us might already know, in Clojure and in all Lisps, code is data. And what does that mean? Well, we represent our code in text files using our language's native data structure literals. And this makes it trivial to generate code because it's just a data structure, and trivial to parse code. Once you parse it, it's a data structure. Now you can manipulate it, you can analyze it, you can project it, transform it, translate it, graph it, work it. Sorry. You can do all sorts of amazing things. So wouldn't it be cool if we could express our architecture diagrams as data in text files and then do some of these cool things with our diagrams? What if we could generate them? What if we could transform them programmatically? What if we could, I don't know, take a whole corpus of diagrams as text files and run some tool that would make sure they were all consistent with each other? Mind-blowing. So Using data in text files, another huge benefit is that it would enable us to use the same workflow for authoring our documentation that we use for authoring our code. And this is a technique, a philosophy that's been developed by a community called Write the Docs, great community, about software documentarians. And it basically, it enables you to leverage all of the rich, robust tools and workflows that have been developed over decades to facilitate and support work, but collaborative work, collaboration via text files. So version control systems such as Git and collaboration systems such as GitHub, GitLab, Bitbucket, Gerrit, Fabricator. These systems are fantastic for collaboration. Many of us use them every day, but they're optimized for collaborating on text files. And they can do very little with the proprietary binary closed file formats used by many diagramming tools. So that's another benefit of using data in text files. And it lets us use this rich ecosystem of tools for collaboration and lets us use a docs as code workflow. I'm being a little facetious though, because as great a technology as data in text files is, cutting edge and everything, it's not quite enough to solve our problems because we also need tools that will render the data into images. Because ultimately we want to create a visual, I guess this is redundant, a visual image. We want to create images that embody and facilitate and engender learning experiences. Effective, efficient, that kind of, like just excellent learning experiences. So we need those tools. Now some of you might be thinking, don't we already have these tools? This is already a thing, right? Some of you are probably like, what is going on even, right? So don't we already have tools that can render diagrams from data and text files? Tools like Graphviz and Plant UML and Mermaid. And yeah, those tools exist. They're really, really good tools and they have their uses. And I've tried many of them over the years. But unfortunately, none of them have ever felt like a good fit for software architecture specifically. And there are a few reasons for this. Let me elaborate. So for example, Graphviz is a very well-known tool, and it's an excellent tool. But Graphviz is all about graphs. I know, weird, right? It's all about graphs. It's all about mathematical graphs. It's obsessed with nodes and edges. And it turns out when you're trying to convey software architecture, you need to do a lot of nesting, a lot of composition, a lot of encapsulation. And Graphviz is extremely awkward for that sort of thing. And that's unfortunate because nested elements are an extremely useful notation in an architecture diagram. Another problem is that all of these tools, maybe most of them, all of them, support only algorithmic layout when rendering diagrams. And that means the tool decides where to position all the elements, how to route the relationship lines, et cetera. Sometimes it's not even deterministic. Anyway, this is great. This kind of thing is excellent. Algorithmic layout is in some cases super, super useful. When you have a large data set on hand and you're creating visualization in order to get a sense of the data, to explore the data, to seek new insights, that's fantastic. But it's not great when you're trying to author a specific coherent learning experience. And it turns out when you're trying to create a learning experience, about a set of elements and the relationships of those elements, being able to specify the layout, specify where each position of everything and the relative positioning, grouping, things like that, the distance between things, the flow, it really, really helps to create an effective learning experience. And whenever I tried Graphviz or Cypher or things like that, I'd find myself wrestling with the algorithms just to get things laid out clearly and usefully. And finally, there's this sort of general purpose problem. So this is a screenshot of Plant UML. I believe there's a list of 18 different kinds of diagrams here. Mermaid supports flowcharts, sequence diagrams, class diagrams, state diagrams, Gantt charts, pie charts. Fantastic, right? The Swiss Army knife. Again, general purpose tools, much of the time that's exactly what you need. Or they're great in general. But the generality of these tools means that they have no specific notations or conventions specifically for software architecture diagrams. And what I mean by that is they lack a conceptual model for how to author architecture diagrams, for how to author a coherent, effective learning experience. In my experience, the lack of a clear, robust, well-defined conceptual model is a significant impediment to people getting involved with creating and maintaining architecture diagrams. I mean, it can be really daunting and a lot of work to have to figure out on your own how to craft a good diagram. And then, because you kind of made up your own conceptual model, your own visual notation, everyone else has to learn how to read your diagram. Without a shared conceptual model, without a tool sort of guiding you, you have to make it up yourself, you've got to learn it, you've got to research it, it's a lot. And let me be very clear though, these various tools, they're great for lots and lots of use cases. I just don't think they're particularly great for this very specific use case of software architecture diagrams. So I just want to summarize the problems with the existing tools. I've made this really massive table because there's just so much information. These are our needs, and these are how the existing tools do. I apologize, this is so small, so complicated. So about 2 years ago, I started a new job at Funding Circle, and I decided I should create a set of architecture diagrams. I wanted to get my bearings in this new context, and I wanted to help others get their bearings at that moment and in the future. I wanted to sort of get everyone on the same page, at least we could have a shared understanding of what our systems are and how they relate to each other. So once again, I tried to use a few tools that could render diagrams from data and text files. And once again, I was frustrated and stymied and aggravated, and I just once again fell back to using GUIs, illustration programs with proprietary closed file formats. And I started doing that work, but I was pretty bummed. And so I kept on sort of randomly, idly searching the web for alternatives and trying to find more diagramming tools, data-driven diagramming tools, and just thinking maybe I missed one somehow. Maybe I'll come across something. I was a little bit wasting time, maybe, I don't know. But I kept trying, and then I found something. I was super excited. I stumbled across Structurizer. And this is structurizer.com, and I'm going to read you what it says there in the center of the page. Have you ever spent hours trying to make a software architecture diagram using a general purpose diagramming tool? Structurizer is a lightweight, web-based modeling tool that lets you quickly create diagrams based upon the C4 model for software architecture. So I said, oh my, the C4 model, what is that? I clicked that link real fast. And it turns out, I wasn't the only one who'd been frustrated with the situation, but Simon Brown had actually done something about it. He created Structurizer, and he created the C4 model for visualizing software architecture. And this is that missing conceptual model that I mentioned earlier, that sort of shared model for just what kind of diagrams should you create? What goes in? What goes out? Just shared models that, it's just so many things it enables. So the name C4 comes from the 4 primary types of diagrams that the framework defines. They all start with the letter C: context, containers, components, and code. And this website's great. Brown has done some really wonderful work here in defining and documenting this model. And if you scroll down on this page, you pretty quickly come across this section: maps of your code. See, Brown also saw a correspondence between maps and diagrams. And in particular, he's organized this conceptual model around different zoom levels. Just as maps at different zoom levels are useful at different times, different circumstances, for different purposes. Sometimes you need a high-level overview of an area, and sometimes you need a block-by-block, highly detailed street map. So too with diagrams. So Brown has done some amazing work. He created the C4 model. He created Structurizer. Again, it's a web-based system for authoring, hosting, browsing, and publishing C4 diagrams. And he also created Structurizer Express. Structurizer Express is a single-page web app that does a bunch of things. It defines a simple data model for C4 diagrams as data. It enables authoring C4 diagrams as data as text, so you can express that data structure using YAML or JSON. It enables authoring C4 diagrams graphically, so you can do direct manipulation of the graphic. You can either edit it, author it in the data or in the graphically, and it keeps them in sync. You make a change to the graphic, it updates the data. You make a change to the data, it updates the graphic. So it's pretty phenomenal. Here's a quick demo. So On the left-hand side, we've got the YAML source of the diagram, and this is just the 0 state, the default diagram. I'm going to paste in a slightly more sophisticated diagram. I'm going to click outside that area to blur it, and boom, it gets rendered. So we've now rendered a diagram from source. And now on the right-hand side, so now you can take a look in the left-hand side. You see the coordinates for one of these elements. I can go on the right-hand side, manipulate it, change the layout, interact with this using direct manipulation graphically. But as I do that, the data is being updated too. And this is just phenomenal. Love this thing. So hopefully you can see there that, this is a way to, it's a rendering tool, and it's also a visual authoring tool. It lets you author diagrams as data in text. And here's an example of the data structure that Simon Brown defined. I apologize, some of it's cut off, but the keys on the left are type, scope, description. Are they cut off on that screen too? No? Oh, great, okay, just on this screen. Okay, great. So this is an example of data structure that Simon Brown defined for structurized Err Express. You can see it's pretty straightforward. You define the elements that you want to appear in a diagram, you give them a type, a name, a position, maybe a description. You define the relationships between these elements, some styles. Pretty basic, I think, straightforward, intuitive stuff. And it works well. And I've been creating diagrams this way for a couple years now. So structurized Err Express is fantastic. It's an excellent tool. But from my perspective, it wasn't quite complete. It didn't get me all the way where I wanted to be. See, I wanted a file-based workflow so I could follow the docs as code philosophy, so I could collaborate using my peers, with my peers, using collaboration tools that we used for all of our stuff. So I've created a tool that wraps structurized Err Express and facilitates that file-based workflow, that docs as code workflow. It's called FC4. And what it does is basically it just facilitates and supports maintaining diagrams as files in a Git repo. I suppose you could use any version control system, but Git is at 99.5%, so be it. So it has various features. So it'll reformat and normalize the source of the diagram source files to prevent noisy diffs. I was having a problem with noisy diffs, these YAML files. And that really got in the way of peer review and collaborating on changes. And so I wrote some code to normalize and reformat that YAML to clean up the diffs, to make sure we always have clean diffs so we can do really good peer review, really effective peer review on the changes. It'll automatically snap the elements in a diagram to a virtual grid, which eliminates some of the drudgery of lining things up in a fiddly GUI, or even just manually manipulating the coordinates as numbers. This tool will do some of that for you. And I think there's room for improvement there too. And it'll automatically render diagrams from YAML to images. So it's sort of like a compiler for the diagrams. This tool is implemented with Clojure. It's open source with a BSD license. And it's been supported by Funding Circle. Here's a hopefully quick little demo of an authoring session using FC4. So I'm in my terminal, I'm going to open up my text editor, and I'm going to open up a diagram. So it's opened up in my text editor. On the left-hand side, I've got the YAML source of the diagram, and on the right-hand side, I've got the rendered image. Now I want to make a change. I forget what change I'm going to make. So any minute now, I'm going to make a change. Oh, right. Now I'm going to start up FC4. So I'm going to start, come on, I'm so slow. So I'm going to start up FC4. I'm going to tell it to watch this diagram and render it when it sees a change. Now it's booting up. It's super fast to boot up because it runs on the JVM. And now it's watching for those changes. So now I'm going to make a change. Come on. Let's go. Okay, so I've decided to move some of these elements over. This is a very simple change. I just want to change the coordinates, right? I want to move everything over. So if I can use the power of my text editor to do this structurally, I don't have to do it manually. And now FC4 saw the change, it's re-rendering, and boom. Boom. So we see the updated diagram there, and it's almost like direct manipulation. I think the latency is pretty good. There's room for improvement. but you get a pretty rapid improvement. So now I've decided to make a more important structural change, a more significant change. I'm going to eliminate a whole element. Decided we don't need that anymore, we got rid of it. So I'm rendering it, and it's re-rendering, and boom, there it's gone. This is a very simple example, but I've edited diagrams of dozens of elements and made significant changes. Now, again, these are files. So the files have changed, the YAML file and the PNG file, and now I can push the changes. I can commit the changes to my repo, I can push them, and we can use a standard collaboration workflow, whatever we're using for peer review, whether it's post-commit, pre-commit, whether it's pull request or merge requests or Garrett or whatever, patches, whatever it is. Hopefully you have some way, some workflow you can use here. And it's been working within Funding Circle really well, and a few other organizations that are using FC4. This is a screenshot of a pull request where you can see the visual diff of a change. So I sent this change out to somebody, to let's say a team member to review it, and I want them to review my change, and they can use the tools in GitHub to see the visual difference. And they can there's three different modes here. There's actually a pretty good tool set. You have 3 different modes here for there's like a difference. There's a side-by-side, there's a onion skin, there's a swiping thing. And this has all sorts of values of use. It's extremely useful. So now, because a diagram is a visual medium, it wouldn't be good enough for people just to see the textual diff and say, oh yeah, semantically that looks fine. Right? This is a learning experience we're creating here. We're collaborating on a learning experience. It has to be a good visual learning experience. It has to have a clear layout that's useful and makes sense. And so I need my peers, when they're reviewing my work and giving me feedback, I need them to see that visual difference. And I need them to comment on it. I need to be able to, so again, this is a pretty simple change right here. We've removed one element. But sometimes I've made significant layout changes, and my peers are able to see the difference and understand the difference visually, and then give me feedback on that, which has just been amazing. So if you'll indulge me, I'd like to talk a little bit about the future of FC4. And I think maybe this isn't too self-indulgent, because basically for me, FC4 has become the vehicle that I use for realizing my vision for software architecture diagramming. And as my vision for diagramming evolves, my vision for FC4 evolves correspondingly. And so they're a dual, and they become aligned and locked. So talking about my vision for FC4 makes this whole vision a little more concrete. In order to talk about FC4's future, I first need to point out a flaw in its current state. And this is the current state of FC4. You can see there's basically 2 elements that make up the FC4. It's the dotted line in the middle, that's FC4, and then this is in context. You can see the elements outside of FC4 that interact with it, knowledge sharers, knowledge seekers, and then structurize or express. So FC4 itself, though, is a CLI tool, and it's a corpus of diagrams. Maybe you'll have 2, maybe you'll have 2,000. Each diagram is a YAML file and a PNG file. Now, over the past 2 years, my colleagues and I at Funding Circle have created a lot of diagrams using FC4. And as we've built up a substantial corpus of these FC4 diagrams in my organization, we've observed increasing duplication and fragmentation in the data. See, because each diagram definition is completely self-contained, and therefore some elements are defined repeatedly in multiple places. Any element that appears in more than one diagram has to be defined multiple times. The name, the description, and really it's the name and the description that are the only thing that really matter there, but they change as we understand our systems better, as we change them. Those things change over time. Hopefully you want them to change as you understand your systems better. You're refining those descriptions especially and helping create those better learning experiences. But anyway, it's been really difficult to get those definitions in sync across these files. And we've been doing so, I wouldn't say it's been really difficult, but it's been a pain in the butt. I mean, we've been doing so entirely manually, which is just tiresome. And it's so tiresome that we often just sort of put it off or just kind of never get around to it. And so to address this problem, I've been working on the next iteration of FC4. We're introducing views and a model. So we're going to change the data model. So now an FC4 corpus is going to consist of a single unified model that contains definitions of all of the elements and their relationships once, right? A single definition in one place, a single source of truth for all of those elements and their relationships. And then a set of views, and each view references the model. It references the elements and the relationships in the model. And the views will yield diagrams. And so I think this is going to reduce duplication, reduce data drift, inconsistencies, and toil substantially. Hope this makes sense. Can I get a nod? All right, thank you. So I've been working on this evolution, on and off, kind of on the side for a while. But recently I've realized that this plan, it doesn't go quite far enough. So it's scrapped. Well, it's not scrapped exactly, it's evolving. I'm just revising this plan. You see, I've realized that as powerful as diagrams, excuse me, are we gonna make it? 5 minutes left. So I've realized that as powerful as diagrams can be, the model of the systems as data, that's actually more valuable, more powerful than the diagrams. You see, it's not just a model, it's also a catalog that is really tiny. I'm sorry. Don't read it. That's the catalog. It's also a model. You can think of it, depending how you want to think about it, right? It's simultaneously a model and a catalog. A static model of a set of software systems and elements and what makes them up and how they work and what they're made of. But it's also a catalog. And it turns out that a centralized semantic catalog as data of our systems can have massive value. In fact, I've come up with a variation of Greenspun's 10th rule. I hope you'll bear with me here. Each department of a sufficiently large software-driven organization contains an ad hoc, informally specified, error-ridden, inaccessible, incomplete catalog of the organization's software systems. Yeah, say that 5 times fast. So sufficiently large organizations need a centralized source of truth for this data. And they need a good way to maintain it and improve it over time. So I'm taking FC4 in this new direction. So it's going to be that single source of truth. Now, instead of being a diagramming tool, it's going to become a toolkit for cataloging, modeling, and documenting software systems. And diagrams will be one of those kinds of documentation that you can be authored and published and maintained via this toolkit. But the central focus is going to be that model or catalog. That's the central, that data set, that single source of truth, that centralized unified data set. That's the core value proposition, and that's the main focus of this toolkit going forward. And there's gonna be various things you can do with the data. Like I said, you can author views. You can render diagrams from the views. You'll even be able to run a single command that will create a read-only website that provides for interactive browsing and querying of that data via a web browser. Also for programmatic querying of the data via HTTP. Single command, boom, Docker image, just deploy it, you got a website. I'm pretty excited about that. This is a preview of the upcoming version of the website. Just to sort of try to wrap this all up and summarize it, FC4 is, well, it's going to be a tool for cataloging, modeling, and documenting software systems. Now, since we're going to be decomplecting the model and the views, we're going to need new data structures. Now, if you recall, the data structure defined by Simon Brown for structurized express was for self-contained diagrams. And each of those data structures contain a full definition of every element and the relationships. So we need new data structures, one for the model and one for the views. And I've designed these new data structures with help from my colleagues at Funding Circle, not just as data structures, but also as a DSL, a domain-specific language. See, I want humans to be able to read and write this stuff easily and intuitively. So here's a model file. I hope it's fairly straightforward. I'm running out of time, so I'm going to move ahead. I hope we can talk about this more later. I'm going to share my slides, but I hope this makes some sense. Basically, you're just defining your systems and their relationship, your people, your elements, and their relationships right here. And hopefully, it's fairly straightforward as a data structure, and hopefully as a DSL. And I'll move that over a little bit, make some room so I can show you a view. And that's a view. And again, it's a separate file. And that references the model. So you basically say, what's the subject of this view? And that's going to be put right in the center. And then you reference the other elements you want to include in your view and what their coordinates should be. And then the renderer looks at the view, looks at the model, puts it all together, and comes out with a diagram. Okay, so just to summarize, if you combine data and text files with the rendering tools, you can get some great results. Awesome diagrams, peer reviews, the same workflow for docs and code. You can generate diagrams from your other data, and a whole bunch of things. Finally, as a sort of meta takeaway, I've come up with a variation on the last element of Python's PEP20 by Tim Peters. Data orientation is one honking great idea. Let's do more of that. So, next time you need to create an architecture diagram, before you break out Visio or Lucidchart or OmniGraffle, try this. Just give it a try. Choose some tool, Mermaid, PlantUML, Structurizr Express, or FC4, or whatever, and find one that has a data format that appeals to you, and author your diagram as data in a text file, and render an image of that diagram using that tool, and then commit those 2 files to your repo. Go through whatever peer review workflow you're using in your organization. I think you're going to find this approach has a lot of benefits, and it'll open the door to new adjacent possibilities that are enabled by authoring your diagrams as data in text files. Thank you.